Good morning, guys. My name is Chini. I'm a software development engineer in a product-based company. Today, I'm here to introduce you to data structures and algorithms using Java. This is coming from Mercy Technologies. Straight away, guys, let me tell you what is our agenda for today. First, I'll introduce what this course or what this session is all about. Then I'll tell you why do we need to learn data structures and algorithms. And then what is the best approach to start learning, practicing, and moving forward. Now, today's topic, as we have already informed in the groups and mails, today's topic is about linked lists. So today I'm going to say what is a linked list, what are the operations, how do we code it, how do we dry run it, and then all these are things. These are pretty interesting stuff, guys. So as we move forward, I'd like to say what are the best coding practices. I mean, everyone in the company, everyone in the interview expects you to follow some basic coding practices. So these are very important things. Let me emphasize on that, those as well. So at the end, let me give you some real-time use cases, and then we can conclude the session. Believe me, guys, this is going to be a very, very interesting session. So I expect a very good concentration from everyone. Just a reminder, guys, the software that we are using has a limit of 101 people. So I'm very happy that the total number of attendees are 101. It's 100%, it's full. Just a word of caution, guys, please do not leave the session in the middle. In case you leave it, then you may not be getting the chance to connect back because there are people who are waiting in a queue. Good thing is, guys, we are recording this session. We would be sharing this once we finish the session. Expecting your total cooperation, guys. Let's dive into our session today. Let me start. Welcome, everyone. Welcome to the session of data structures and algorithms using Java. A very warm welcome from Mercy Technologies to each and every one of you. Glad that you had a time to spare with us and learn something new today. Appreciate you all, guys. Let me go back. Let me start. So we have an agenda today. Let's see, why are we learning data structures algorithms? What are the things to be learned in data structures algorithms? How or what is the approach that we follow to learn data structures algorithms? And let's straight away go into learning linked list and its set of operations. Let me start, guys. So to learn everything or to learn anything in the life, we need to have some motivation. Here you go. This is the motivation, guys. Every one of us try to code, learn to code. But how do you create or how do you term yourself a good coder if you don't know how good your code is? Or let's say, how do you measure the quality of your code or the efficiency of your code? This you can do when you have good knowledge on data structures and algorithms. And believe me, guys, calculating time and space complexity is the heart of every program. And we are going to dive deep into this and make yourself or make sure that we are writing better code than our peers. I think this should be a good motivation for us to start with. Now let's start seeing, why is data structures important in computer science? I have been speaking with different placement officers in different colleges and have connected with different people who hire for big product companies. I asked them a straightforward question. Why is data structures and algorithms important in computer science? And I was stunned with his answer. His answer was, data structures and algorithms is not important in computer science. It is computer science. Guys, believe me, data structures and algorithms is computer science. If you are well with this basic, then you can term yourself or you have all the basement ready for yourself to grow forward in your career or maybe see yourself in a big role in the near future. Let's go back, guys. And one more thing, why do you need to learn data structures and algorithms? Data structures and algorithms knowledge differentiates you from the huge IT crowd. I still see people who are in manager roles, but they are not able to calculate how good their program is. They don't know good about data structures and algorithms. So if you have knowledge on this, guys, there are lakhs of people who are striving to get a job, and this knowledge will make sure that you're different from other people and you are in a position to be hired because you have some extra skill that is not easily obtainable and that is not easily possessed by everyone in the IT industry now. And that's a very good motivation for us. Let's go back. So appeal, guys, I got this feedback from my previous students, my previous sessions. Sometimes I tend to speak very fast because in that flow, I try to, speak very fast. So in case I'm fast, guys, just let me know, ping me personally in WhatsApp. I'll make sure that my pace is a little bit reduced and so that everyone understands what I'm trying to teach. Believe me, guys, this is going to be a very interesting session. Do not leave in middle because if you leave, you do not get a chance to join back. So with this, guys, I just I'll just move forward. Guys, somebody messaged me personally, like if you're able to hear me properly, just ping me in WhatsApp group. If there is a problem with my audio, guys, if you are able to hear me properly, clearly, please message me in WhatsApp. It may be a problem with a single or particular person. Great, guys, great. Thank you for your reply. Let's move forward, guys. We got a good motivation on why do we need to learn data structures and algorithms. Now, let's move forward and let's see what to learn in it. Believe me, guys, it's a big ocean. When you start Googling it, you'll find, man, it's too big. It's very hard to learn. Having knowledge on this is it takes a lot of time. This is what I hear from different people, but believe me, guys, this is a very basic concept, right? It's easily learned by many people provided you get the correct guidance and you put it with your proper mind presence, right? That's what is important, guys. Now, what are the various data structures and algorithms that we need to learn or that are asked in the interviews or that are required for you to say, yes, I have good knowledge on data structures and algorithms? Now, on the left side, I'd like to present what are the data structures: linked lists, stacks, queues, trees, graphs. There are different others, but these are very important. And now if you go to algorithms, people ask, what is a Dijkstra's algorithm? Explain me what is Bell-Manford algorithm, Floyd-Warshall's algorithm, Prim's algorithm, quicksort, bubble sort, whatever sort it is, radix sort. So these are all the algorithms, guys. These, believe me, all these are seeming fancy. These seem to be big names, but believe me, all these are less than 10 lines of code, guys, provided you are writing a better code. And just let me, before I forget, I'll say any data structures and algorithms questions that are asked in the interview will be having a code of less than 20 lines. If you are trying to write more than 20 lines, then maybe you're doing something wrong. Maybe you're going somewhere wrong, right? These are very important and very easy to learn, guys. But the thing is, we need to learn it in a proper way, right? Let me go back. So all these are big things, but do you know, guys, we are already using them in our real life. Let me tell you. Linked list we already have. We will surely be listening to some music player in our Android or iOS mobile phones. Linked list is used in a music player. It goes to next song or the previous song. We use linked list there. I'll go to stack, guys. You have a habit of having opening different things in your browser. Let's say you want to go back, then how do you go back? All those pages which you have previously opened will be stored in a stack internally. We have operating system, be it iOS, be it Android, be it Windows. We have OS job scheduling in the operating systems, and this is done using a queue. And we all have mobile phones and the computers, right? We have file systems. How are the file systems done? Folder A inside folder B inside folder C, and there is a folder D. So all this is stored using a tree data structure. Graphs, no need to mention, everyone uses Google Maps. Google Maps internally uses graphs data structure. So let's say we try to write something on Word or anywhere, Notepad plus plus. So there will be a red line which coming under any spelling we write. It says it's a red line, right? It's because the spelling that you have written is wrong. But how does the editor know that the spelling that you have written is wrong? It may be some weird software that it has, but the thing is, guys, you are using a try data structure internally. So guys, you are already using your data structures. The only thing is you need to learn how are these to be coded and how can these be used even in a better way. Now guys, let's move into how to learn data structures algorithms. What are the better ways to learn data structures algorithms? What would be our approach? So my thing, guys, let me come back to the end of the session. I'll tell you what is the best approach. I'll tell you what are the resources at the end of the session. This is very important, guys, don't miss it out. So this will be a short session. I'll not take too much of your time. This will be a short session. At the end, I'll be coming to the approach that you need to follow. At the end, I'll be giving you the resources that you need to follow, right? But let me tell you, why is Java convenient to learn data structures and algorithms? There are different languages. People tend to teach in C, C++, Python, Ruby, or whatever language. But Java is convenient to learn, guys. The reason is Java is really verbose. Java is easy to read and understand, even if you don't know anything on programming language. If you say a method, add, right? Or if you say something, it is verbose. I mean, the moment you see it, you may feel, okay, this does this particular thing. That comes intuitively in your mind. And that's the reason why I'm using Java to teach you data structures and algorithms. One more important point is Java has a huge community support. Believe me, huge community support. And then there is a third point. There are plenty of resources available online. Let's say you try to learn it in C++. Let's say you try to learn in C. You try to learn it in Python, whatever. But what I understand is the number of resources available online in Java are second to none, no comparison. So you will be in a better position to make sure that you're learning in a proper way. Let's go by, guys. As I told you, I'll tell you the approach at the end. I'll tell you the resources at the end, for sure. So let's not waste any time. Let's go hands-on. Let's go directly into what we are trying to learn today, which is linked list data structure. Linked list data structure, let me dive deep into whatever we are trying to learn today, guys, right? So let me start. All concentration on the presentation now. Here you go, guys. Linked list data structure. Linked list data structure is a physical data structure. See, there are two types of data structures. One is physical data structure, and the second thing is logical data structure. Arrays and linked lists are called physical data structures. The reason why they are called as physical data structures is they are actually or physically present in the memory. It's not a representation. It is the actual presence in the memory. You take a stack, you take a queue, you take a graph, you take a tree. All these are logical data structures. We are logically saying that a tree should be in this way, that a graph should be in this way, but linked list is actually physically present inside the memory. That's why it's called as a physical data structure. Let me reiterate, guys. Arrays and linked lists are called physical data structures. Trees, graphs, arrays, trees, graphs, stacks, queues, all these are called as logical data structures. Now let's go with the representation, right? Representation of a linked list is very simple. One thing, it has two nodes, guys, right? It has two nodes. One is data, and second is a link that connects it to the next node. The whole thing is called as a node. Node has 2 points. One thing is data, and the next is the link. As I'm mentioning it over here, guys. It has the address of next link. People may ask, Java has no pointers, Java has no addresses, Java has no this, Java has no that. It's all, see, it's not present to a programmer, guys. We all like most of us are familiar with a null pointer exception. If Java doesn't have pointers, then how come there is a null pointer exception? Java has pointers, but it is internally present. It's not present to the programmer, unlike it is C or C++. So that's why Java is famous, guys. Pointers is a little bit hard to learn, is what programming community says. Java has come out of pointers and it became a very famous language. Now, many people, there's a vast community going on around Java. That's a different story, guys. But what I wanted to say is how we represent a linked list node is in this way. It has a data, it has a link. This is a single node, right? So let me go back. Now let's see what is the representation is all about. This is a simple diagram, guys. This is a very simple diagram, right? This is a node. All these are the nodes, right? So how do we have a link to that node? That is called as head node, right? Remember, guys, head is the heart of linked list. If you lose a pointer to head, then all this data is gone. So it's very important for us to remember that we are trying to do something with this head node. We should be very cautious, because if we lose this, then we are losing all this, because this is addressless. It's gone somewhere in the memory. You can't even access that. So be sure that when you are trying to do something with the head, be very cautious. I'll tell you when we go hands-on, guys. I'll tell you that, right? So now there is a head, there is this head, and it points out to the node, and this node is pointing out to the next node. This node is pointing out to the next node, and finally there is the end. It says it is pointing to the null, right? So important points to be remembered here, guys. A linked list has a head and it has a null. Guys, just one more. I got a message from some other person that he's not able to listen to my voice. Just ping me in WhatsApp if you are able to hear me clearly and properly. Waiting for your messages, guys. Just ping me, guys. Ping me, guys. Hello. Yeah, guys. Thank you for your reply. Cool, guys. Cool. Superb. Everyone is able to hear me. I got so many responses. I'm good that many people are active today. Yeah, guys. Let me reiterate. I think I missed something in the middle. Every linked list has different nodes, and every node is connected by a pointer, right? And important things to be remembered in any linked list is it has a head that marks the start of the linked list. There is a null which marks the end of the linked list. These are very important things. Only three important points, guys. One is node, second is head, third is null. That's it. So this is all basic that you need to learn about data structure. Data structure and linked list, guys. Let me go back, right? So uh, now let's go to what are the operations that are there in linked list. Let me not confuse you. For any data structure, be it be physical, logical, any data structure, we have these things. We need to create it, we need to traverse it, we need to insert it, we need to delete it, right? For any data structure, we are talking about only linked list. In our case, we need to create a linked list, we need to traverse the linked list, we need to insert some node in the linked list, and if required, we need to delete that. And these are the 4 basic operations. Remember this as a thumb rule, guys. Any data structure that you learn, try to learn how to create it, try to learn how to traverse it, try to learn how to insert and delete. There are 3 different cases while inserting and delete. Inserting first, inserting last, inserting at some particular point. In delete also, deleting first, deleting last, deleting at some particular index, right? These are the only things, guys. Don't go to all different fancy stuff that many websites teach us. Don't do that. It's very important, very simple to learn. Let's make the things very simple. Okay, if you learn all this, guys, all your base is ready. Now all the interviews, all big interviews, people who ask in Amazon, Google, Facebook, all these are dependent on this basement only. If all this basement is proper, then believe me, you can crack any interview question. Let me make sure that I'll tell you the correct approach for that. Before that, guys, let me tell you a few thumb rules that any programmer, any language, anywhere, he should follow these things. Let me read it out, guys. These are very important for your whole life as in your career as a software engineer. Let's say you go to an interview and people ask for you to write some code, or let's say your manager asks you to code something. By looking at the method signature, interviewer should come to a conclusion that what you're trying to write in it. And the naming is very important, guys. The method names should be meaningful, return type should be proper, and there should be correct set of parameters. If this is fine, 50% of your problem is solved, guys. How the people interview, how the people evaluate you in a coding interview is just by seeing the method signature, you're half selected. Believe me, you're half selected. And the rest is the logic. And the rest is logic. Beat any interview, guys. I'm not speaking about data structures and algorithms interview. The method signature, proper naming conventions, return types, these are very important. And this is 50% of what you code. And now let's come to the second point. Every method that you write should have boundary conditions. This is one more thing that interviewers tend to look at, how good your coding is. For the check, you need to check for null conditions, you need to check for empty conditions, because if you don't check, then the quality of the code that you're delivering is improper. There'll be bugs which will be coming. Many bugs which come in the industry, believe me, guys, are null pointer exceptions, are the ones which are having empty conditions. If you are able to handle this in the signature or in the first line itself, believe me, you will give a very good impression to the interviewer. And final, last but not the least one, guys, write clean code with proper indentation if you are writing it on a piece of paper. Because let's say we are writing it in IDE, yes, we will write it, we'll do Control Shift F, it indents and everything is done. But most of the interviews are done on pen and paper or whiteboarding, right? You need to make sure that you're writing it with clear indentation, because indentation is very important. That's defining the quality of your learning, right? This is very important, guys. So let me not waste any more time. I think all this is proper. All this is proper, right? As I told you, I'll come to this analogy after the end. At the end, maybe I am done with my first program, guys. So let's go hands on. But here there is one thing. We are done with the okay. We are done with the thumb rules. Let's start coding, guys. Okay, I'll be using Eclipse for coding. For those who don't know what is Eclipse, it is an IDE for coding in Java. That's very easy, guys. We'll try to write a simple program and try to dry run it. See, important thing is, after you write your code, you should make sure it's working properly without the compiler, without actually running it. You should be sure that it's running it properly, and that we will do it by dry running it. I'll teach you what is dry run after coding the first program, right? Come on, guys, let's go hands on. Let me open Eclipse for you now. So let me start from first, guys. Okay. What happened? Give me a second. So as this goes, I'll tell you what is our progress now. We are done with the introduction. with why do we need to learn data structures and algorithms. So this one, as I told you, I'll tell you at the end, guys, is very important. Okay. Now we are doing with this fourth point, linked list operations, coding, and dry run, right? And one more thing, before the fourth, I'm done with fifth point as well, best practices. See, there are n number of best practices, guys. We cannot learn 100% of best practices. That comes with experience. But the points that I have written covers at least 60% of your best practices, and you learn as you code, right? Coding is not an overnight activity, guys. You will learn as you code. That's very important. Okay, guys, let me set up my project quickly. Not sure why Eclipse is giving me a problem today. Yeah. Yeah, guys, let's start. New project. I'm trying to do a Java project. Okay. Let me name DS and this is a proper name for a project, guys. That's fine. Eclipse always asks you to want which perspective or whatever. So yeah, you can do it in case you need it. Right. So let me create a simple class. Before that, let me try to write one thing, right? So how do we represent? Let's take the same example that we have taken, okay, for the representation. So what is it? What is the example, guys? There is a head, there is 28, 27, 26, 25, and null. Let me try to put the same over here. Head. Uh, is pointing out to 28, 27, 26, and null, right? Let me view it as Java language so it'll be easier. There is, I think I opened it in a wrong way. Yeah, okay, sorry guys. It should be language. Sorry, I was looking at the perspective of Notepad. Right. Guys, I got a message that screen is struck and you're not audible. I hear from few people that the screen is stuck, it's not refreshing. If you're attending from laptop, guys, so make sure that you refresh. Let me check my internet speed because I have good internet connection. Let me do that. Okay. Good guys, you see it's almost 90 Mbps speed and that's too much. Tell me, guys, in case you have any problems. You have any problems with? You can ping me message. You can ping me personally in WhatsApp. Uh, Guys, one more thing that I want to say is we will record the session and we'll be sending it to you for sure. Don't worry, just try to refresh. I just made sure that the internet connection from my end is proper. Let me continue, guys. Let me continue. Okay. So we were seeing the same representation that we needed with the example that we have taken. There is this head. Let's say this is a node, and then these are the data points, right? This is the representation, guys. Now, first thing that we need to learn about coding is how do we represent it, right? Let me create a class. Let me name it as node, right? Oh, sorry. Let me put a package, right? Let me make it node, right? In case if you have issues, then we can increase the font as well. But I think, yeah, this good good font. So as we see, the thing is in our representation, what we have an integer data, and simple, guys. This is the representation. We have a class called node, we have integer data, and we have an X pointer. And in Java, we need to have a constructor. This is not mandatory, by the way, but it's good to have. I'll tell you, as we code, we'll be able to understand it. I'm going at source, generate constructor using fields, and I want to have a constructor with only data, right? So here you go, guys. We are done with our representation. This is simple representation. Guys, this is very simple. This is just, as I said, the number of lines is less than 10, right? This is how you represent the node of a linked list. Now the representation is done. If you see in our presentation, the first thing that we need to learn is the representation. So how do we represent? We came to know how to represent it. This is how we represent it. This is a Java class. Now let's see. Let's try to generate, or let's try to make sure that we are having a linked list like this, and we are traversing it. Right? We are traversing it. Let's try to do that, guys. Let me try to write a new class. Okay, and I'll name it as LL traverse, linked list traverse. Okay, so I told you guys golden rules. We need to make sure the method signature is proper and interviewer understands what we are trying to achieve with the method signature that we are having, right? It is public void traverse. And what we are trying to traverse? We are trying to traverse a linked list. So to try to traverse, we need to have the head pointer. We have head. Now we are sure what we are returning. We made sure that the naming is proper. We made sure that the parameter is proper, and our method signature is proper. Now, guys, before trying to write anything in the method, make sure that you handle all your base conditions, right? So what is the base condition here? If head equal to null, then you don't do anything. Don't come into my method, return. That's it. So you're done with the base condition handling, guys. So if it is null, then you return. Don't come into my method itself. So if not, as I told you guys, head is very important. Having a pointer to the head is very important. Let's say you lose this, then you lose the control to all this, right? Now, let's make sure we are not losing the pointer to head. So that is the reason I'm taking node P equal to head. Let's say we do anything from now, the operations, we are doing it on P and we are not doing it on head, so that we are not losing the control to head, right? So how do we write? We need to write it now. We need to traverse and try to print what are there, what are the nodes that are present inside the linked list. Now, let me do it, guys. While P is not equal to null, P is not equal to null, come into my loop and say system.out.println. Here we are trying to print p.data, p.data. Right? So just for our convention, I'm trying to print one more space after it. So what I'm trying to do, I'm saying p equal to p.next, and that's it. We are done with our first program, guys. It's very simple. We are done with our base condition. We are not modifying anything in the head, and here we are traversing and we are making sure that we are printing the data. It's very simple, guys. I showed you how to write it. Now let me try to dry run this code for you. We should make sure, as I told you guys, we should make sure after we write without even compiling it, we should make sure it's running properly with all the base conditions answered, right? So here on line number 9, what I made sure, head equal to null, then you written in our input. This is the input for us, guys. In our input, head is not equal to null. It is pointing us to 28, right? It's not null. So we are not going into this condition. Now we are in line number 12. What we are doing, we are taking a variable p and we are pointing it to head, right? Let's say we are pointing it to head. What we are taking, we have taken a variable called p, right? P is pointing to 28, right? On line number 12. Now we came to line number 13. P is not null. Yes, P is not null. P is 28. Now we are trying to print P. Here, let's try to write the output, right? We are trying to print P, which is 28. And after that, we have a space, right? And after that, what we are doing in line number 17, we are making sure P is equal to P dot next. P dot next is 27, guys. Now P has moved to 27. So again, it came to line number 15. So again, P is not null. Yes, we are trying to print what is there with P now, 27, right? Again, we came to the condition. Now the P is moving to 26. We are printing 26 again after having a space. And now P is going to null, right? So if P is going to null on line number 15, if we see when P is null, then we are coming out of this while loop. You see, there's nothing in our program now. So actually, guys, we made sure that our program is running properly. It has the base condition. It is checking the null. We have the correct while loop. We are trying to traverse it, and we have printed it. It's so simple, guys. It's that simple. Let's say you try to search in Google how to traverse a linked list. You'll be getting so many programs which just you need to scratch your head, say, what is this kind of? But actually speaking, it's so easy. It's so easy to understand how to traverse a linked list. That's it, guys. We are done with our first program. I hope you understood what we tried to write in this program and how we achieved that. So this is the first program for us in the linked list, guys, and how we dry run it. In case you have any doubts in it, or if you are clear with it, just message either yes or no or whatever you feel in the WhatsApp so that I can go ahead. I just wanted to make sure that people are following me. Waiting for your replies, guys. Let's see if people have understood it. Good, 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 good. I see people messaging me. I see people messaging me. Thank you for your replies, guys. I'm still waiting. Good, good, good. People give me smileys. People give me symbols. I'm liking it, guys. Good, guys. I'm still waiting for your replies.
Hey guys, thanks for joining this course. Mainly we thought of doing this effort. So again, we will come back. So don't leave the class. We thought of giving one introduction, and after that, again, our trainer Karthik will be resuming the course. So we plan to start on data structure on 26th. Today is 6th, right? So if you observe. So what we planned is we plan to start a new batch on 18th of thing. So we'll just go for an announcement. So Karthik, actually what is happening is the trainer is a real time guy. So he is working in IT. So I want to give some introduction about the trainer. So this effort we are taking from Mercy Technologies. Okay. So Chinni, he will be trainer for you. Chenny is the trainer who is taking the current session. So what we planned is he is working in IT. He is a software engineer, and you can say he's a Java developer. I can say he's a Java developer, and he's having around 6+ years experience in IT. In IT industry. And good thing is that he is having he is very good in data structure, and he trained in past around 2 years he trained many members. So many members they got job in product based companies, so we could able to see their involvement. Even we had multiple training sessions on data structure. So this is the introduction about the trainer, and he is having around 2+ years experience in teaching. So what we do under Mercy Technologies umbrella, so we have group of software engineers. We all joined together. We formed institute called Mercy Technologies. So our motto is we need to teach everything in real time. Okay, everything in real time. So people lack in real time. So how we can study and how we can use all the concepts in real time. So this is what we are doing, and we are starting a new data structure course. Okay, we are starting one new batch, okay, on data structure. Data structures, let me put it in a short form. Data structures, so we plan to conduct daily 1 to 1.5 hour. It will be on weekdays. Okay, weekdays it will be on 1 to 1.5 hour. And what is our approach is from practical to theory. Okay, our approach will be mostly from practical to theory. Okay, from the code you need to understand the all the concepts. So data structure is very one of the important concepts. You guys might be knowing it. So we will be using as a Java, but if you don't know Java, no issues. 80% concept will be data structure side, and 20% we will see how to achieve through programming. So, and it will be on weekdays, 1 to 1.5 hours. The course duration is around we are planning it for 2 months. Okay, 2 months. Hence, Chinni is working in the IT industry, so he needs to, morning we will be having. Mostly it will be, 8:30 to 9:30. Okay, so we will try on the morning time the course. First we will go with 1 hour, then we will increase. So basically, it will be 8:30 a.m. IST to 9:30 a.m. So we'll be sharing our syllabus to you. If you are really interested, you can ask us. So we'll be sharing our syllabus. So let me show the syllabus. This is our syllabus. So we will cover in-depth means in-depth. It's not like what is meant by linked list. Linked list only it takes around 5 hours class. I think you can say like around 5 days classes, right? Linked list only takes around 5 days sessions. If you see under linked list, we are having too many topics. Traversal, insert first, insert last, everything we are having, right? So we are having many topics. So linked list, if I am not wrong, Karthik Chinni is telling it will take around 6 to 7 days for completing linked list. So like that, we will cover in depth. We will take one topic. We will, try to see what are the options are there. We will cover very in depth. At the end of the course, you should be expert in data structure, whatever knowledge Chinni has. So same knowledge you will be getting it, and even you could able to crack any product based companies, either it is Amazon or whatever company. You should able to crack the interviews. That's our main motto. Even for working people also, they enrolled our course already. People started enrolling it, around 20 people enrolled. So even working people also they enrolled, because they also want to go to some high level product based companies. So our motto is to teach everything from practical point of view, to cover to take each topic and cover very in depth. Finally, end of the course, you should be very good in data structure, and also very good in practical, where to use, how to use. You should be able to crack any interview. Suppose if your interview is asking, can you write your own linked list? Chinni is explaining how to write our own linked list, right? This is what. So this is the interview question. Surely they'll be, you guys might be aware, in interview they'll be asking, write your own linked list, write your own queue, write your own stack, implement your own data structure. All these things they'll be asking. So our motto is, as Chinni is explained today, line by line. So everything we will be explaining line by line. So that is our motto. So end of the course, our the quality should be very higher. We should teach very in depth. Finally, it should be beneficial for you guys. That is our motto. So let's go back. So this is our thing. If you have any doubts, you can ask. Some people, they are asking about fees. So we are planning to charge around 3,000 rupees. Okay, you can attend 2 3 free classes, that's fine. So but we plan to charge around rupees 3,000. You can say like outside they charge around, if you, this is in Mercy Technologies we charge this much. But I'm sure very less institutes only they are teaching data structures. Majority of the institutes, they teach all the programming languages, everything. But very less institutes, they teach data structures, but they charge minimum very higher amount. People who are working real time, like Chinni, same way, like Chinni are from Mercy Technologies. So people who are teaching, they charge, you can say around 18 to 20,000, 18K 20K they are charging. So we planned, at least the fees should be reasonable. Let it be very less, that's okay. So we will try to give more, quality, so that we can do. Suppose, sir, you might be having, sir, this is quarantine time, we are having issue, no problem. We can give you 2 installments. You can pay first installment 1500. You can join the course. So you see how it goes. For surely, we are having other batches also, like, Java, all other batches we are having. People whoever joined, if I, they are having very good feedback. Current batch on Java batch is running around 30 to 35 members. They paid and they joined the course. Around 1 month got over. Everyone is very happy because under Mercy Technologies we teach very in depth. So same quality we are expecting. So fee we are charging this. So you can attend 1 or 2 classes freely. If you are really interested to learn data structure, we will take care of you. At the end of the course, even we will try to help you to attend the interviews wherever, openings are there. Even we have tie-ups also. So we are trying our best because it is quarantine time. You guys might be knowing, like, companies are shut down, so everyone, we are working from home, but we will try our best. So I am handing over back to Chinni, so you will continue the class. Please be in the class.
Anybody asked anything, Shashi? Yeah. Guys, thank you for listening to whatever Shashi has said. We are a group of software engineers, guys. We are not, hardcore training institute people. So we are already working. We are doing it out of passion. And that is the reason, if you see the amount of fees that we charge is pretty much less. We just wanted to, give our knowledge to maximum number of people. That is our motto. Uh, let me come back to whatever I was teaching, guys. Whatever I was teaching, I'm sure that people have understood how do we traverse a linked list. There are two important points that we have learned. First thing is, how do we give me time, guys. So how do we traverse, how do we represent a linked list, and how do we traverse a linked list? There are two important things. So I'll not eat up your time, guys. Let's go to one more simple program so that you master whatever I have taught till now. Okay, let's move to. But let me go back to the presentation once. Where are we? There is one guy who personally pinged me and asked me that, and the question was, why did you represent? Why did you represent the next pointer of type node? This is this is a simple question, guys. What do we see here? Okay, let me go to the diagram so that will be easier for you. So here in the representation, this is the data for particular node, and this is a pointer, right? The type of this pointer, the data type of this pointer should be of node, right? It should not be of data, integer, string, anything. The data type of this pointer should be of type node. That is the reason why I have declared next to be of type node. I think it answers your question. It's a straightforward question, but yeah, it's the first time that you're learning or seeing it. Maybe that's the reason you had this question. But yeah, that's good. Let me go back. Let me go back. Erase all the drawings. Right? Where have we been, guys? Let's go to a small analogy. I like learning things. I like learning things when they are surprising, right? This is a small detective movie that I've actually seen. Just give me a second, guys. Okay, so what is linked list data structure saying? Linked list data structure is saying, I know a guy who knows a guy, right? I don't know where I got this picture from, but actually this comes to the reality, right? So what happens? There is a data structure. What is it saying? It is saying, I know a guy who knows a guy, right? Who is that guy? Who is that guy? This is a node and it knows one more node. This is a node, it knows one more node. This is a node, it knows one more node, right? And thing is, guys, people bring about double linked list. See, generally when someone asks anything in interview, when he means a linked list, which means by default it is a single linked list. Like generally when we say biryani, by default it is a chicken biryani. We don't mean paneer or veg or something like that. So whenever somebody speaks about linked list, he is speaking about a single linked list. Don't assume that to be a double linked list, because by default it is a single linked list. And if the interviewer wants to test your knowledge on double linked list, he explicitly mentions that he is speaking about a double linked list. Let's go back, guys. Let's go back. Okay, let's go back. Operations. So operations, we came to know what, how to create it. We are done with this create. We are done with this traverse. Now I do not want to waste most of your time, but let me try to take one simple program of insert, and I'm dealing with this insert first. Okay, insert first. Now we are okay with creation. Now we are okay with traversal. There is this thing called insert first. So let me be very clear, guys. Inserting first. I mean, yeah, as we go hands-on, you'll be able to understand that, right? Let me remove everything. Okay, right. So I'm creating one more class. What is that class? Let's name it as, okay, it's class, right? Let's name it as insert first, right? So as I told you guys, let me try to take a method. So what are you trying to return? Let's say you're trying to insert something, then you're modifying the way you access the linked list. So which means when somebody wants to insert something in the first, he need to have the access to that point, because if he doesn't have the access to that point, he lost all the linked list somewhere in the memory. So what do? We'll return node. We'll try to, we are having a method that is returning node. And what is it expecting? It is expecting head, and it is expecting some data. Now, just to remove this red line for now, guys, I'm saying return null, right? Here, we are done with the signature. What is it returning? It is returning a node, and we are trying to insert something on first. What are we getting as an input? We are getting head as an input, and we are getting some data that we want to insert. Now, let's move forward. Let's try to code the base condition. Base condition, right? What is the base condition? If head equal to null, return. Return what? Return null, because there's nothing. You have given me a null linked list, so I'm returning you the null linked list because I do not want to insert anything. So there is an assumption, guys. For example, let's say somebody wants, we have given you some data, right? Some data. So why don't you create a new node and return it? But yeah, we can do that, guys. But let me put the code in a concise way. My assumption, null when head is null. So this is very important, guys. Whenever an interviewer wants you to code something, you need to ask him right questions. You need to ask him questions, and make sure you need to ask him right questions. The people who interview will expect the person to ask questions, but let me reiterate, asking the right questions. So the question would be something like this: I already have some data, right? Why don't I create a new node and return it? Then the interview might say, no, I just want to have a method that returns null when head is null. So this is the requirement that you got it from the interviewer. So based on that, you have written a base condition. Okay. Now let me move to the next part. So what it says, one more important thing is, guys, we need to think loud in interview. Think loud means whenever an interviewer asks you to write something, you need to write and you need to speak. Forget about it. Interviewer is listening to you or not. Forget about it. Don't shout, by the way. Just try to recall something in your mind, saying, okay, I'll write it here. Okay, I'll write it here. Why do I write it? I'll write it here. I'll write it. The reason we do it is this gives the impression to the interviewer that you're doing something. And very important point is if the interviewer is a helpful guy, when you're thinking aloud, which means you're speaking out whatever you're thinking, he might guide you. Boss, this is not the correct direction. Go in this way. You can achieve the solution simply. So it means you are making your interview easier by thinking aloud. So how am I thinking aloud? Okay, interview has given me this. Let me write from line number 8 to 10. Yes, head is null. I've written the base condition. So now what I should do? I should okay, I should not modify anything is head. So let me do something which is node p is equal to head. I told you we should not modify anything in head. That's the reason I've taken node p is equal to head. Okay, we are done with one more point. Now what we have to do? So guys, okay, fine. What we have to do? What we have to do? We have this data called x. Let me try to create node q is equal to new, oh sorry, new node of x, right? So now you have one more node which is having the value of x. What do I do now? I have to make sure now this q is the first node because we are inserting something in first, right? What do you do? Q dot next is equal to p and return q. And you know what? We are done with the coding. That's it. This is how you insert first. Let me remove comments. Let me dry run this. Let me dry run this so that we'll make sure whatever I write is proper, right? Let me remove everything in my notepad. Okay, so here it is. Here is our code. Be very attentive, guys. Here we are going to learn something. So what we are taking, okay, travel. Sorry, I copied the wrong one. I copied the wrong one. Okay, be attentive, guys. We are learning something new here. So what we are doing in this code, we are trying to insert something first, which means we need to have some node which points us to this node. So this is our input, guys. Okay, let's say I'm trying to insert, let's say the value of x is 29. So here our input is x equal to 29, right? So now, so how it should be x equal to 29, right? We got it. So now what we are doing, we are creating something called node p is equal to head, right? What we have done on line number 11, we have created a node called p. We have created a node called p and we are pointing it out. We are pointing it out to head, right? This is what we are doing it on line number 12. Now let's go to line number 13. We are creating a new node and we are pointing it out, and we are pointing it out. This is the default value, guys. We have created something like this q, right? So we have something like this. Now we need to make sure we are inserting this to the start. What we are doing on line number 16, we are doing q dot next is equal to p. As of now, q dot next is null, right? We are trying to put, what we are trying to do, this q should be pointing it out to P. That's what we are doing in line number 16, right? So now what I'm doing here, as part of this q dot next equal to P. So this q dot next, which is null now, let me remove it. So this is P, right? Let me bring it and let me place it. So what is happening? Q dot next equal to P. Q dot next is equal to P. Actually, P is this. P is this. And yeah, we are done. And we are done, guys. So what happens? This becomes our head. So what happens? This becomes our head. And let me bring it properly to Q is pointing out to the head, P is pointing out to the next node, and we are returning Q, which means we are returning the head. And we have inserted something in first, and we are returning the pointer to anyone who calls our method. And it's so simple. It's very easy to dry run. We have maintained our base condition. We made sure that we are not having any null conditions. And we are making sure that we are asking the right questions to interviewers and making sure we're impressing them. We are impressing him by writing as low code as possible and making sure it's as clean as possible, right? It's that simple, guys. It's very simple. It's very simple. So how do we run it, and how do we dry run it? How do we give inputs to it? How do we learn it? This all, let's see it. Let's it takes a bit more time, guys. It takes a little bit more time. I just want to emphasize one thing. If you are able to write something which is very clean, if you are making sure that your code works without before running it or before compiling it, then you are done. You are a very good programmer. That's it. So these are two ways of coding, guys. You can either have a braces on your same line, you can have braces of second line. There are people who argue the first method is better, second method is better. That's fine. Every coder or every programmer has his own way of coding things. But the important thing is you are trying to learn how your logic is. You're trying to see that you can write code in a cleaner, in a precise way. Let's go back to our presentation, guys. Let's go back to our presentation. I told you that I will tell you that one thing at the end, right? Let me go. So I told you we are going to hub. I told you why we are using Java. See, I'll reiterate this. Using Java, anyone who comes and sees this code in the first time, when you see this method, okay, insert first, it's taking something, it's returning something, it's a public one. Okay, it's very easy. I mean, it has right number of lines and it has a right way of learning or understanding things. One more important thing that I wanted to say here is, guys, so I said that I'd be showing you what is the right approach of learning anything. Forget about if it is data structures or algorithms or anything that you want to learn. It has two different approaches, if I'm not wrong. One is BFS and second thing is DFS. So these are two programs, two very important programs, very important interview questions in data structures and algorithms, guys. One is breadth first search and depth first search. So this, let me go to an analogy, right? Let's say you are given something to learn, right? Let's say we are learning something about the linked list. First we'll see how to traverse a linked list, how to insert first, insert last, etc. There is one way. Let's go to depth first approach. What happens if we use the depth first approach? First we'll learn what is data structures and algorithms, then about the linked list, then about the interview questions in linked list. Oh, Microsoft questions, Facebook questions, whatever, anything in the world, you try to learn everything about linked list, then you come back, right? You try to learn everything about it, then you come back. You go deep inside and then you come back, deep inside, then you come back. You learn something about linked list, deep inside, then you come back to trees, deep inside, then you come back to graphs. And I feel this is not a proper approach, guys. How should a proper approach be? You should go through everything in the syllabus, make sure to one certain level. So that second approach is called as breadth first approach. Let's say you try to learn something up to certain level, you are okay, you are clear. You are able to crack some very good companies if you are able to crack this data structures algorithms up to certain level, guys. Then you go to deep. Then you go deep. If this is done, then you go even deep. This is breadth first approach, right? I like breadth first approach. It's up to anyone. It's up to anyone who wants to learn anything, right? I like breadth first approach. So the approach that we are learning in this course is also breadth first approach, guys. I'd like to first introduce you to linked list, try to make sure that you're learning everything and finding and make sure that you are comfortable to certain level. Then I'll go to trees, then I'll go to graphs, then I'll go to what do you call some other data structures like stacks, queues. What happens is as we move forward to the next level, there are interview questions which are linking between two different data structures. Like interviewer may ask you, try to create a queue using two stacks. Try to create a linked list using an array, right? There are permutations and combinations. Try to create a graph using linked list, graph using array. So this happens only when you're comfortable until a certain level. I'll make sure that you will have that grip, and after that you'd be able to crack, or you'll be able to solve most of the interview questions. So let me not waste more time, guys. My last slide for you for today's presentation is the resources. I told you what are the best approaches. You join this course, do not join this course, whatever, it's up to you. But what is the best way to learn something? Learn something in life. Let me. What are the right resources? Let's say if somebody's pointing out to you and say, hey guy, you can you learn it? How much time will you take to learn it? Kind of. You need to find out the best resources. You need to find out, or you need to ask the right questions to the people. I tell you, learning algorithms. There is a book called Cracking the Coding Interview by Gail Lackman. I have it, guys. It's a must-have book for every programmer, if I'm not wrong. I think you can download a PDF version, but I like reading hard copies. I have a book. I bought it on Amazon. And there is one more website. So this is a book, and there is a website called Geeks for Geeks. This is a big ocean, guys. Believe me. Once you start into that, then you don't know. You'll be lost somewhere, right? But you make sure that you're following your pattern, following your syllabus, and you're making sure that you are solving at least easy and medium problems that are related in Geeks for Geeks. There is a rating, guys. How do you rate this question? Is it an easy question? Is it a hard question? Tough question? Very tough question, kind of. So based on that, you make sure at least you solve this easy and medium questions, right? And then there is a practice tool called a hacker rank. Okay, maybe in the tomorrow session I'd like to go hands-on on the hacker rank and try to see how different how it works in a different way, how it works in a proper way. How do we test our code? How do we make sure that we are writing a proper code, kind of. Tomorrow I'd like to emphasize on space complexity, time complexity. Any code that you write, guys, if anyone asks, you have written a code something like this, right? What is the space complexity? What is the time complexity? Can you tell me? Can you tell me how efficient your code is? You should be in a position to answer that. Tomorrow I'll be making sure that you will be becoming master in calculating time complexity, calculating space complexity, and making sure that you write clean, fresh, beautiful code. You'll be impressing interviewer, guys, and believe me, impressing an interviewer in the interview is the first step to crack the interview, right? We'll make sure that we have a good grip over time complexity, space complexity, writing a better code, following the golden rules, following the thumb rules, and finally we make sure that we are in a better position to understand better of what we are writing, right? So this is the last thing that I wanted to say in our total presentation, guys. Forget about any other thing. I tell you, these are the resources, whatever in the world. The thing is, you as a person should have the zeal to learn more and achieve big. If you don't have this, even if you join a course which is worth lakhs of rupees, nobody can help you, guys. If you have the zeal to learn more and achieve big, and if you get the right resources and if you get the right people, then believe me, you will be moving ahead in your life tenfold than your peers. So with this, guys, let me end this. And it's very happy for me that most of people have attended, people are following me, people have messaged me in WhatsApp. Like to thank you for your time, guys. Let me hand it over to Shashi. So guys, let me reiterate. Tomorrow, as I told you, we'll be concentrating on time complexity and space complexity, calculating that, writing better codes, solving 2, 3 more interview questions, trying to see whichever is the best, right? Tomorrow, it's the same time, guys, 11 o'clock. We'll be giving you the link, and tomorrow and maybe the next week as well, I'm not sure, but we'll be having 3 sessions. I'll make sure that you have this base ready. You try to know how to calculate space and time complexity. This is very important before learning data structures, algorithms. See, following the resources, everything, it's my personal choice, guys. It's my personal choice. I've been successful following these resources. I do not recommend you, or I'm not endorsing anything here, but these are good things. These are good things to go. And at the same time, let me reiterate, guys, if you do not have the zeal to learn more and achieve big, no resource worth lakhs of rupees can help you, right? Let's have the positive mindset and attitude, guys, to learn something good and achieve big, and let's move on in our life. Thanks a lot for your time, guys. I'm very happy for this, and let me hand it over to Shashi.